Okay, let's talk about the fundamental counting principle. Now, what this tells you is how many ways two or more events can occur together. So let's look at some examples. A coin is tossed and a die is rolled. Find the number of outcomes for each sequence of events. Well, for a coin, you have two choices, heads or tails. So we put down two. For a dice, you have six choices, 1, 2, 3, 4, 5, and 6. So we put down 6. 2 times 6 is equal to 12, and that gives us the number of ways that the events can occur. Let's look at another example. A paint manufacturer wishes to manufacture several different paints. How many different kinds of paints can be made if you can select one color, one type, one texture, and one use? Well, there are 7 colors, 2 types, 3 textures, and 2 uses. So we would multiply 7 times 2 times 3 times 2, and that gives us 84 different ways that can occur. The next thing we're going to talk about is permutations. Now, permutations are an arrangement of n objects in a specific order. That's the key. You need to remember that permutations are needed when you have a specific order. It is the arrangement of n objects in a specific order using r objects at a time. Okay, and I'm going to give you a couple of examples. Now, the calculators today have buttons, NPR. So you need to get your calculator and locate the button. If you can't find it, then you can Google it, look on YouTube, check your owner's manual. But you'll have a button on most calculators that give you the button for permutations. Now, N is the number of objects. R is how many you're taking at a time. So let's do some examples. A business owner wishes to rank. Rank is the key here. That means order matters. The top 3 locations selected from 5 locations for a business. How many ways can she rank them? Well, you always put the larger number first. N is how many you've got. So it's going to be 5P3. She's choosing 3. When you plug that in the calculator, you get 60. There's 60 different ways she can rank them. Here's another one. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guest is important. Okay, so they tell you order is important. Okay, that means it's a permutation. How many different ways can this be done? Well, she has 6. She's choosing 3. Bigger number always goes first. And if you mess up on this on your calculator, it's going to give you an error, so you'll catch it. So if you type in 6P3, you get 120 different ways this can be done. Now, permutations is when order matters. The next slide talks about combinations. Combination is without regard to order. For combination, it doesn't matter. It's like a committee, okay? It doesn't matter what order you're picked in. If you're on a committee, you're all just members of a committee. So it's the same thing. N objects, R at a time. So you have a button on your calculator, NCR. So locate this button. The first example I've got, how many combinations of 4 objects are there taken 2 at a time? So we would do 4C2, and you'll get 6. There's 6 different ways to do that. Another example, the director of movies at the park must select 4 movies from a total of 10 movies to show on movie night at the park. Order doesn't matter for this, we're just showing movies. So how many different ways can the selection be made? Well, we start with 10, we're selecting 4, so it would be 10C4. We use C because order doesn't matter. That gives you 210 different ways this can be done.